Welcome to Harcourt University once again. Now, today we are going to discuss a problem under mechanism synthesis. And in this problem, we are supposed to move an object from position 1 through position 2 to position 3. Now, the problem says we have an assembly line where objects of the same sizes must be moved through 3 positions, 1, 2, and 3, using points A and B as attachment. Now we'll be adding a dyad with the following constraints. So what we're going to talk about here or mention are the constraints that the dyad should obey. So the dyad shall be attached to the coupler with minimum angle of rotation from one position or one toggle position to another. And secondly, all pivots and moving parts of the dyad shall be on the base EFGHI. Now, third, the coupler of the dyad shall be aligned horizontally. So we need a horizontal dyad. And the last one, the dyad shall obey the Grashof condition of rotatability. Okay, so our task is to design an acceptable 4-bar mechanism to move the object through the 3 positions using pivot A, B. And also, the pivot point for A should be O2 and that for B will be O4 respectively. And we will list the lengths of the 4-bar mechanism. Then we add a non-quick return dyad. We will label we use an electric motor, okay, to limit the positions to the toggle position 1 and 3. And then label the ground pivots of the dyad as O6. Label the other moving pivots at all positions with your own label with subscripts 1, 2, and 3 respectively. So let's get into it. Now, before we begin, if you have not subscribed to the channel, kindly do so to support us. I need to reach 1,000 subscribers and 4,000 watch hours to get on the playlist. I mean, this is how you can do, or this is what you can do to pay me for my effort. Without your support, I can't keep doing this video being broke. So kindly subscribe and keep watching. Let me know your take or your questions in the comment section. Thank you. All right. So we begin by finding the pivot point for point A and point B. And we do that by doing our normal bisection. So we join A1 to A2 with short dashes. And then you go to A1, A2, A3, A2, A3 with same short dashes. Okay, next you use the compass to bisect the line joining A1, A2. So you open the compass more than half, you make an arc, and then move to the other position, you make an arc, you make an arc. So after this, draw your bisector. Okay, and you bisect A2, A3 as well. So you use the same approach. More than half. Let's use a different color. Make an arc. Make an arc. Then go to position 2. Make an arc. So when we are done, join them. All right. So where the 2 bisectors meet will be the center of rotation for what? A, and we label that O2. All right. So we will join a length from A to O2. So the length will be the coupler link will join from O2 to A1, and then at position 2 it will be here, at position 3 it will be here. So I want this to use black for those. So in your work, you make these lines very thin. It shouldn't be thick line. And then when you are drawing the links, you will use thick lines or deep lines to not make your work messy. So join a link from O2 to A1. And then we go to A2, join a link, you go to A3, all right, so we are done with A. So the link will join A1, A2, A3. So let's go and do for B. So in your work, you will do this first and go before you go to B. Don't do all the short dashes before you come and do the bisection. You can easily miss a step. If you have mastered this, especially for my students, I think for you can do whatever you want because you know what you're doing. But if you are now learning this, you do them in stepwise so that you know or you don't miss the steps. So next you join A1 to A2, A2 to, no, we've done it for A. So you join B1 to B2, B2 to B3. Good. So at the end, we have the fixed point for B, and we are supposed to label that O4. All right. So the next is to join the length from the O4 to B1, B2, B3. All right. So I can begin from 3 or 2 or 1, whatever I want, because I'm just joining the B to its pivot point that I found, which is O4. So I'm listing the lengths. This is what it means by listing the lengths. Sometimes you can just make the mechanism be in position 1. So you see that this is just position 3, right? And then the rest I'll make them short dashes, or I'll make them thick line. And because the lines are many, just make them thick line for all the 3 positions. And then I have this last one. They have this. Okay, so we are done with the instruction E. So what did the instruction A say? Design an acceptable 4-bar mechanism to move the object through the 3 positions using point A and B as attachment. Label the ground pivot of the point A and B as O2 and O4 respectively, and list the lengths. So that is what we've done. We've identified O2, O4, and then we've drawn the links to both or all the moving pivots. So let's move on to the B. The B says add a non-quick return dyad, and the quick return should follow this procedure. So we're going to attach a dyad to our mechanism, and let's see how we do that. Now, before we continue with that, if you've not subscribed, kindly hit on the subscribe button to support the YouTube channel. Thank you. So before we attach the dyad, they ask us to the constraints over here. The constraints, the 4 constraints here, they said what? The dyad shall be attached to the coupler with minimum angle of rotation. What that means is that between the length moving from O2A1 to O2A3 and the length moving from O4B1 to O4B3, the one that uses the minimum angle. So I'm going to measure the angle between O4B1 and O4B3, and then O2A1 and O2A3. So I want to begin with the O2. All right, so the angle for O4B1 to O4B3, I have 1 30 degrees. So angle O, no, let me just say B3, O4, B1, whatever you want, is what 130 degrees. Then let's measure for A1, O2, O3, A3, right? I mean, I believe now everybody knows how to measure an angle. So you just make the horizontal line here align with one of the lines, and then the center will be at the fixed points, which is where the angle is made, and then you count, right? So for here we have 120 degrees. 120 degrees. So I think 120.5. I'm just making 120. So the angle A1, O2, A3 is 120 degrees. So clearly the line or the link O2A1 moving to O2A3 uses the minimum angle, and that is what you are going to attach the dyad to. Now over here it looks messy, right? So I'm going to reduce the lines a bit, right, so that you can get or you can understand what I'm doing. Now in your work, don't clean a lot of stuff. If they are obstructing what you are doing, that's fine, you can clean a bit, but these lines are important. They are going to mark them. So not like you just need the construction lines and then after getting the links you have to clean the arcs you've made. No. So I want to attach the dyad. Now the dyad, I don't want to put it up here because the up there is very messy. So I would want to bring them down. But the constraint said we need to what? Attach a horizontal dyad. From the third point, the coupler should be what? Horizontal. Okay, so the dyad too, we should have the subscript 1, 2, and 3. So you need to pay attention to this. All right. So I want to clean this bottom a bit so that I can really demonstrate what I'm doing. In your work, kindly do not clean anything. In your work, because the lace lines are not going to use thick lines, you should have an easy space here to do whatever you're supposed to do. So these lines wouldn't obstruct you that much. But now I have to demonstrate what I'm about to do to you. So I need to clean the place so that the place will be neat for you. Okay, so to attach the dyad, we are going to attach a horizontal dyad. All right, so to do that, you first draw a horizontal line. Now how do I make sure I'm drawing a horizontal line? You first align your straight edge. You align it with the edge of your sheet. All right, not the box. You can use the box too, something like this. This one like this. So you align this one to this like this. All right, then you will move it up a bit so that it will align with the points here. Good. Then you draw your horizontal line like that. Hey. Now the next is to draw a perpendicular line to the horizontal line at this point O2. Don't forget, this is our O2. So we do this alignment and then we draw our perpendicular line. All right, so you need to pay attention. So having done with this, we have the horizontal line, and then we have the horizontal line, and then you have the perpendicular line to that horizontal line. So we are supposed to measure the angle made by O2A1 and O2A3, and that angle has been measured already as what? 120. So you will divide the angle into 2. You need to pay attention. You divide the angle into what? 2, which will be what? 60-60, right? 60-60. So you come to the vertical line and then measure 60 degrees to your left, 60 degrees to your right. So you bring your compass, your protractor right here. Then you let the horizontal, you let it align like this. don't make it like this. Don't do it this way. If you do it this way, then you have to know that you are starting from 0 at 90. So you move 10, 20, 30, 40, 50, 60. All right. Don't just count 60 to your left. You might make a mistake. So just align the 0 line with the vertical, move 60 to your left, then you do the other way around. So here 60 is here, right? 60 is here. And then you turn to the other way around too as well. All right, so the zeros is the line. The zero, if you turn it this way, the zeros are the ones here, right? So the 60 aligns with 120. Okay, so the 60 is somewhere here. All right, so now you take your protractor away and you bring the straight edge. Come on, I want this one. You bring the straight edge. So you draw a line from that 60 you marked to the point 02. All right. Kindly subscribe to the channel if you haven't. So I just join from here to here, and then I join the other one too. The other 60. Okay. So we have this too as well. All right, so now that we have these two lines here, we choose any length from along this line and then attach our dyad, right? So attach our coupler. So I want to choose this point. I want to choose a point somewhere here. God, they said everything's supposed to be in this here. The moving pivots and the fixed pivots of the crank and coupler should be within the box EFGHI. I don't want to have a bigger a bigger crank. All right, so you would choose a length that is reasonable and can fit in here. So I'm choosing a point. Let me use a different color. A point somewhere here, right? Okay, I'm likely not to be able to draw this. So if I choose this point, then I'll use the compass to locate at the other position. So let's bring our compass. Let's see if you can squeeze that in to that length. That'll be hard. Okay. So I think I'm facing a little challenge here. So my compass, I can't reduce it to the size that I want. All right, so I'm going to work with it. It's going to go beyond, but yours should not go beyond the box. So you need to choose a small point as I did earlier. All right, so from here, that means since I can't use a very small radius, I have to bring it up somewhere here. So let me just extend this line. And then, okay. So my tools are not permitting me to do what I'm supposed to do. So I squeeze it to the minimum, and this is where I can get it. So this is the length I can have. So I'll attach the dyad here, the coupler here, and then I'll mark it here, right? So what the question was asking you to avoid is the point coming out. You see, so if this is running, the pivot point here will run on this arc, and then it will come out of the EFGHI. So in your work, it shouldn't come out like this. Everything should be contained within the EFGHI. So from point 1 to 2 should be within. Now the question asks you to label them 1, 2, 3 by yourself. Now from what you've done, the link A1, O2 will continue here, right? So this is your position 1. Your position 1, your link will be aligned like this: A1, O2, and this link, right? So if this is my position 1, I want to label the point where the coupler attaches the output link or the coupler link as what? E1 here. That means I'll have E3 here. All right. Now, after you've done that, what you need to do is to join E1 to E3 and extend the line to any length of your choice. Now, of your choice, of course, but it should be within the box EFG. In your case, in my case is different, right? So you join E1 to E2 and extend it to a length of your choice. Mine is going beyond, but yours shouldn't. So yours, if you choose a very small point somewhere here, the red part, and you draw it, if you extend the line, it should be within. I getting it. Now I'm making it go out because if it's somewhere here, because of the radius I have here, the whole circle will take over the space. That's how I've made it go beyond. Now I'll take the length from here to here with my compass. So what you do is that you bring your compass. I'll take the length from here. Sorry. So I'll take half of the length E1, E3. I'll take half of it, and then with the compass, and then come to this point and draw a circle. So let's see how that goes. So you come to E1. So just let's create this guy. Okay, so we have it now, right? How do you transport it? Okay. So you take it to the point here, and now draw your circle. And now draw a circle at that point. Okay. So if you follow what we are saying, this circle is supposed to be within the box EFGH. The circle is supposed to be here. So you choose at the red point, then you take half of the length as we did with the compass, you extend the line within the box, and you make your circle very small so that no part of the circle will come out, and here to E3 wouldn't come out of the box EFG. All right, for the sake of demonstration, because the digital compass I have here is not permitting us to use or do as small as we want, so we need to use this. Okay, quick. So now we are done. Here is already E1, E3. Now our coupler and the crank at E3, the coupler will start from E3 to the tip here, right? So I want to use F for the position of the coupler and the crank as position 1 and 2, 3 as well. So here is going to be what? F3, and then at position 1, our coupler will be at the back there. You extend the line to touch the other side of the circle, and then you label it what? F1. All right, F1. So we have F1, E1 at the coupler length, or F3, E3 at the what? Coupler length. So the next is to find the position 2 for the coupler. So what you do, pay attention. What you do is that you measure the angle that the link will make from position 1 to position 2, right? So O2A1 to O2A2, what angle do we have? So let's bring our guy here and measure the angle we make by moving from O2A1 to O2A2. That is 51 degrees. All right, 51 degrees. So we will come to A1. The link E1 O2 is the link joining A1. All right, so we come to E1O2 and measure 51 degrees to the right, because if it is moving to position 2, the E1O2 moving to the right. So we align our compass with E1O2. E1O2 like this, and 51 is somewhere. You bring your straight edge. Okay, so now what we are saying is that at position 2, if the link O2A1 moves to position 2, the link E1O2 will be here. So you have E2 here. You have E2 here. All right, so E2 will be on this point. Let me just. So E2 will be here. Okay. Now the length F1E1 or F3E3 will always be the same. All right, so you would want to locate F2E2, and to do that, we will measure F3E3 or F1E1 and come and stand at E2 and find the F2 on the circle or the crank. So with your compass, you stand at one end. Let's stand at F3 and take the measurement to E3. So you take the coupler length, which is F3E3 or F1E1. So you bring your compass and take the measurement F3E3, or you can use F1E1 as well. So after doing that, you put your pin at the E2, and then you go to the crank. You make an arc here, and you see there are 2 places the arcs can be made, right? You make another arc here too as well. So with this, what that tells us is that the coupler will be here, F2 on the crank at position 2, maybe when moving forward or backwards, and another one here when moving forward or backwards. So you are done. You've been able to, let's go to the instruction. You've been able to attach a dyad with no quick return, and then on the minimum angle, and then okay, I couldn't fulfill this, right? So yours, like I'm saying, choose a very small point and let everything lie within the EFGHI, and then a couple of that shall be aligned horizontally. Yes, I also achieved the horizontal dyad by the process horizontal line, vertical line, measure an angle here, and then drawing this, and then yeah, previous. Okay, so label the ground pivot of the dyad as 06, right? Supposed to label here 06, and check for Grashof condition for rotatability. Okay, so this, you see there is one here. These are just constraints, and the instruction we're supposed to do this, you've done it, and then we're supposed to do this so that to fulfill this constraint. You've done that, except for this for me. And now you are supposed to check for Grashof condition for rotatability. So this, you have to check. You see there are 2 of them, right? So I suggest you check this for the mechanism itself. So with the 4 links we have here, so just measure the O2, O4. So for the C Grashof condition for rotatability, we have O2, O4 length, O2A length, O4B length, and then AB length, right? So these 4 lengths, the shortest plus the longest should be less or equal to the sum of the other 2 sides. If this is true, then Grashof condition for just the length is what satisfied. O2A3 is the same length that you have for O2A2, O2A1, and O4B3 will be the same for O4B1. So just O2A that you say, and then O4B that you say, right? So this will give us the 4 length for Grashof condition. Now you have to measure the angle O2A from position 1 to 2. That's what we measured as what? 120. So O2A, they're asking for A1, O2, A3. O2A, we are measuring the angle made about the O2, and that was 120, and then definitely the O4 will be what? 130. All right, so the length O4B from angle toggle position 1 to 3, that one is measured. Measure the distance O2F. So we have O2 as a what? O2 is here as a ground for A, and they're asking you to measure the distance between O2 and what? F. Now this is the F. This is the F, right? And this is the ground point O2. So I'm measuring the distance between O2 and what? F here. Now with mine, let me see what I can get. So I have 8.2, 8.6, right? So my distance O2F is what? 8.6 cm. Now we are supposed to measure the distance O4F. So just as you did for O2F, you do for O4F too as well. So now you just turn your straight edge and then go to what? O4, and that is 9.9. So O4F is 9.9 cm. The last thing is to check for Grashof, right? So we have to check for Grashof for the dyad. Okay, so this one will be for the whole mechanism, like I said here, and this one will be for just the dyad. Now let's see how we do that. So for the dyad, what length gives us the four lengths for Grashof condition? So we have the O6, O2. The dyad is connected to this link here with the ground point O2. So we need the link O2, O6, or O6, O2. We need the length O6F. We need the length EO2, and then we need the length of the coupler, which is what? EF. All right. So the coupler length, you bring your straight edge. The coupler length, we have 12.3. So EF 12.3 centimeters, and then EO2 or O2O6. Let me do that first. O2O6, I have 12.5. And then what else do I have to measure? EO2, right? So EO2 we have 4.7. EO2 we have 4.7 here, and last bugger here, O6F, that is 4.2. So the longest is 12. So the condition says the shortest plus the longest should be less or equal to what? The other side. So the longest is 12.5, obviously. The shortest is 4.2. And that gives us 16.7. We are saying that should be less or equal to 12.3 plus 4.7. And this is giving us 16.7. So 16.7 is less or equal to what? 17. So I have 16.7 less or equal to the other two sides is going to give me 17 centimeters. So since 16.7 is less than 17, we say that what? Grashof is met. All right, so the Grashof condition for the dyad has been done, and then the Grashof condition for the whole link here has been explained. So with that one, you measure the length. I've explained that, so yeah, that should be fine. All right, so this is what we have, or this is how you go about the three position mechanism synthesis with a horizontal dyad and non-quick return. Now, if you enjoyed the video or you learned anything, kindly subscribe to the channel as a means of support to allow us to do more of this. Thank you for watching. Have a good day.